And here we are again to go over another practice test to ensure that you are prepared to ace the test on Tuesday. Yeah. So, one thing that was brought to my attention is it seems like eons ago that we studied absolute value equations because a lot of you forgot or you didn't utilize your toolkit. So let's refresh our memory. When we're solving absolute value equations, we first need to isolate the absolute value by applying properties of equality. Okay, so I'm going to write that over here to give myself some more space. That's why you have this space. Then I'm going to divide by 10. So I got all kinds of answers here. But the answer is absolute value. Well, we have absolute value of n equals 2. So then I need to write two equations, n equals 2 or n equals negative 2. Because if we go back and check it and plug it in, if I have a negative 2 in here, absolute value of negative 2 is 2 times 10 is 20 minus 6 is 14. If I plug a 2 into there, it also works. So we will almost always have two answers when it's an absolute value equation. All right, number 2, we would subtract 10 from both sides, and a lot of you got caught on this. Absolute value of x equals negative 9. Can I take the absolute value of anything and get a negative outcome? No solution. Yeah. Number 3, I would add 1 to both sides, and I get absolute value of p over 5 equals 1. I'd multiply both sides by 5 and get absolute value of p equals 5. So p equals 5, or I need to consider the negative value, negative 5. Because 5 and negative 5 are both 5 units from 0, and they both make that a true equation when I plug them in. Okay, number 4. Now this one comes out a little different. I've already isolated the absolute value, so now I just write two equations. One, x plus 1/2 equals 5, or x plus 1/2 equals negative 5. That's it. Okay? So then I just solve them separately, subtract 1/2, and I get x equals 4.5. And over here I subtract 1/2 and get x equals negative 5.5. So a lot of you got one of the problems right, but you forgot that there's two possible values because of the absolute value. All right, moving on. Then we went to inequalities. So those were equations. These are inequalities. When it starts out as greater than or equal to, it's an OR. Okay, we just got done with compound inequalities last unit. So this one we would write as 9x is greater than or equal to 27, or 9x is less than or equal to negative 27, because we need to consider the negative option. And when we multiply both sides by a negative, it reverses the inequality. We don't change this because this was an absolute value. So here we would divide by 9 and get x is greater than or equal to 3, or divide by 9 and get x is less than or equal to negative 3. What does that look like? X is greater than or equal to 3. X is less than or equal to negative 3. It's a union of the two graphs, or a combination of the two graphs. So my final graph looks like that. Okay? All right. Number 6. Same dealio, except this is an and, because it starts out as less than or equal to. So we have negative 4x is less than or equal to 40, and negative 4x is greater than or equal to negative 40. So pretty simple once you understand how you write your two inequalities. The solving is pretty simple, I should say. So divide by negative 4, x is greater than or equal to negative 10, because when I divide by a negative, I reverse the inequality. And the same dealio here, divide by negative 4, x is less than or equal to 10. So when I look at that, x is greater than or equal to negative 10, x is less than or equal to 10, where are they both shaded? Well, in between negative 10 and 10. Let's look like that. Okay, number 7. It is back to an OR here. D minus 3 is greater than or equal to 2, or D minus 3 is less than or equal to negative 2. So I would add 3 and get D is greater than or equal to 5, or, what did I put there, or, or, and then here I'd add 3 and get D is less than or equal to 1. What does that look like? D is greater than or equal to 5. D is less than or equal to 1. And then it's a combination of the two graphs. One or the other is shaded here and here. Number 8. This will be another and. D minus 4 is less than or equal to 1, and D minus 4 is greater than or equal to negative 1. Add 4. D is less than or equal to 5. Add 4. D is greater than or equal to 3. And where are they both graphed? Just in that little section between 3 and 5. All right. So far, so good. So a lot of you realize that you didn't need to make a table because we've done enough translating of the parent function that you've realized what it looks like. So this is going to be, it's going to go start the vertex will be at -2, and we're going to go up 1 over 1, up 1 over 1, up 1, -1, and this is going to form our parent graph shifted 2 units down. Use the proper ray here. It's our parent graph shifted 2 units down. So that -2 on the outside shifts the parent graph 2 units down. Killing me, Smalls. All right, here we go. There we go. Oh.
You watch that, man.
Okay, the reason I'm doing this is I want you to see that this really becomes our graph for a lot of these graphs. Here, if I have it negative, what's that going to do to my parent graph? Make it upside down. And if it's +5, that means it's going to be 5 units above. Okay, so that's what that one should look like. Next page. If we have, now this one I can't do like that. So this one, I would probably make a table. X, 2 absolute value of x minus 3, y. If I put in -2, -1, 0, 1, 2, let's see what I get out. 2 times absolute value of -2 is 4, minus 3 is 1. 2 times absolute value of -1 is 2, minus 3 is -1. Here we're going to get -3. Here we're going to get -1. And here we're going to get 1. So then we have -2, 1, -1, -1, 0, -3. So it's similar to the parent graph, but it's taller and skinnier because it increases twice as fast. So this one should look just like that. All right, write an equation for each translation. So if it's 2 units down, we learn that it is absolute value of x minus 2. If it's 6.5 up, it's absolute value of x plus 6.5. Then, is this going to be our parent graph again? Yes. It is going to be our parent graph shifted 3 to the left. Remember, if the number is inside the absolute value, the sign will be the opposite. It moves the opposite direction. So instead of going 3 right, it goes 3 left. Okay? This one, again, this will be a good time to make a graph. I know it's going to open up upside down. I should say make a table. It's going to open upside down. I'm going to make 1 my middle number because that's going to give me 0. So I'm going to go 1, 0, -1, 2, 3. So at -1, I get -2 times absolute value of -1 minus 1 is -2. That's 2. So I get an output of negative 4. At 0, I get negative 2 times 1, which is negative 2. At 1, I get negative 2 times 0, which is 0. At 2, I get negative 2 times 2 minus 1, which is negative 2. And at at 3, I get negative 4. So again, I have my negative 1, negative 4. I have my 0, negative 2. I knew this was going to open downward because of that negative there. I have 1, 0, which is my vertex, 2, negative 2, and 3, negative 4. And that makes my absolute value graph. Okay. Number 16, same dealio. I'm going to make a table. One half x minus 3 minus 5. So I'm going to make 3 my middle number. Okay. What happens when I put in 1? I have 1 half times 1 minus 3 is negative 2. Absolute value is 2. Times 1 half is 1 minus 5 is negative 4. When I put in 2, I have 1 half times 2 minus 3, so it's negative. It'd be positive 1 half minus 5, negative 4 and a half. When I plug in 3, no one should be talking. I hear people talking. When I plug in 3, I get 0, minus 5, negative 5. When I plug in 4, I get 1 half minus 5, negative 4.5. And when I plug in 5, I get negative 4 again. So what does that look like? 1, negative 4. 2, negative 4.5. 3, negative 5. So it's going to look like this. And so it's going to be quite a bit wider because of that 1 half on the outside. Okay. Write an equation for each translation. 3 units left. How are we going to move it left? Put x plus 3 on the inside. How are we going to move it right? Put x minus 16.5 on the inside of the absolute value. And which of these following inequalities? This one threw some of you guys a little bit. This first one. This will be n minus 1 is less than 2 and n minus 1 is greater than negative 2. What do I get? N is less than 3 and n is greater than negative 1. Well, what does that look like? That. Okay? Number 2. This one you would get x is less than 3 or x is greater than negative 1. That's no. And that would be going, that would be the whole number line because they're going to go the opposite direction. So, and it's an OR. So that would be all. If it was an and, it would be right, but it's an OR. So you got busted if you thought that one. Someone came up to me and thought it was all 3. I don't recall who that was. Now on the third one, whoop. All right, the third one, we have 1 is less than 3h plus 4, and 3h plus 4 is less than 13. So we subtract 4 and get negative 3 is less than 3h. So we get h is greater than negative 1. Is h greater than negative 1? Yes. It's an and, so I'm thinking this one might work. When I subtract 4, I get, so this took you back to last unit. 3h is less than 9, h is less than 3, so that one works too. Yep. The reason I like to put those questions on tests is the Smarter Balance Assessment has quite a few of those, where you have to, select all that apply. I know, but you have to test them all. Write an equation that will transform y equals absolute value of x wider, upside down, move to the right, and move down. So what needs to be true? What needs to be true for it to be upside down? Wider.
1/2.
A number less than 1. I would have used a half. You could use -1/3 and -1/4. It doesn't matter, right? And then if you want to move it to the right, it has to be minus something. Okay? And if you want to move it down, minus on the outside. So you could have put any number here, minus. You could have put any number here as long as it was minus. This had to be minus, and this had to be less than 1. That's all. So there's an infinite number of right answers, but that's what I was looking for there. Now I think this was a great higher level thinking question.
Oh, yeah.
Okay, so this one, I don't know if I saw anybody with the right answer, but if you think about it, and I'm going to just paste my paragraph here. If you think about it, where do I have 2x intercepts? When in the paragraph's like that, right? When do I have 1? When the vertex is on the x-axis. When do I have 0? There's no x-intercepts. Never going to cost you exactly. So it's possible to have 0, 1, or 2.
So, let's say how many bananas? Yeah, so it's like.
Right.
So like how many? So it implied that it was
Oh, so
given
did
the
you say
highest
like
number.
I don't think that implies that.
Yeah.
Well,
That's kind of what the group consensus is.
All who?
Right.
How many possible x-intercepts is it possible to have?
So you should-
Or 1. Or 0.
That's why we said it.
Right. Up to 2 is 0, 1, or 2.
We can add them together.
It didn't say what is the maximum number. Okay, so obviously maybe it wasn't the best written question.
Yep. Yeah, let's just take them.
Well, it doesn't matter, right? Just practice.
Let's just burn it. Burn it to get our grade.
How would you write that to get that answer then? What are all the possible numbers of x-intercepts you can have?
What is the maximum number of x?
But that's not the question I wanted to ask. I didn't want to know what the maximum
What
was.
are all the available x-intercepts? It's supposed to tricky because some people don't know that there's multiple ones, so saying what are all of them? Like that would be
Okay. Okay, fair enough. All right, the bonus. So if we want the optimal operating temperature to be within 10 degrees of 190, we need to take the absolute value of the ideal temperature minus 190 has to be less than or equal to 10 units away from 190. We did a few word problems like that in class, just like that.
Oh, it's
So you would get T minus 190 is less than or equal to 10. You get T is less than or equal to 200, and then you would get T minus 190 is greater than or equal to negative 10. So you get T is greater than or equal to 180. So it's going to be anywhere between 180 and 200, including 180 and 200. So you're
I thought it was the optimal operating temperature was within 10 degrees and 190 degrees, so anything within it. And so I did the absolute value of x plus 100 was less than 90.
So the inequality is this. The solution is, right? It says within 10. Well, 180 is within 10. Okay.
That's true.
Anyways, so the good news is it was a practice test, right? You know exactly what you need to study for. So this will be put in Google Classroom for you to look at over the weekend.